Hi everyone. Today we're going to look at reacting mass calculations. I call them reacting mass, other people might call them something else. They come in the form of, if I have this number of grams of something, how many grams of something else do I make or do I need? So let's have a look at an example question. What mass of calcium oxide could be obtained by heating 25 grams of limestone, which is calcium carbonate? The first thing we need with these types of calculations is the balanced equation, and often this will be given. Here we have CaCO3, when it's heated, produces CaO, calcium oxide, plus CO2, carbon dioxide, and our equation is balanced. The next step is to look at the question. What is it asking me about, and what does it tell me about? In this case, the question is asking me about the calcium oxide. What mass of calcium oxide? I'm going to start with this. Could be obtained by heating 25 grams of limestone or calcium carbonate. It tells me about the calcium carbonate. We can actually ignore everything else and start our calculation. I find it easiest to set out a small table. In the table, we need the mass in grams, the MR value or the molecular mass of the compound, the number of moles, and the ratio. And we'll come back to this later. What can I already add to the table? Well, I can already add the mass in grams of the calcium carbonate because I'm told that it's 25 grams. I can't add the mass in grams of calcium oxide. That's what I ultimately want to calculate. I can work out the MR value of calcium carbonate using the mass numbers from the periodic table. So 40 is the atomic mass number of calcium, plus 12 for carbon, plus 16 multiplied by 3 for the oxygen, which gives me a value of 100. From this we can calculate the number of moles, as moles is equal to mass divided by the MR value. So 25 divided by 100 gives me 0.25 moles. I now need to look at the ratio, and the ratio comes from the balanced equation. How many moles of calcium carbonate react to produce how many moles of calcium oxide? Here the balanced equation shows that we have a ratio of 1 to 1. We've not needed to add in any balancing numbers in our equation, so the ratio is 1 to 1. It therefore follows that if I have 0.25 moles of calcium carbonate, I will also have 0.25 moles of calcium oxide. Now we can calculate the MR value for calcium oxide. Calcium, if I look in the periodic table again, is 40. Oxygen is 16. This gives me 56. Now I can calculate the mass in grams. We know that mass in grams is equal to the number of moles multiplied by the MR value. So 0.25, number of moles, multiplied by 56, the MR value, gives me 14 grams. And this is my final answer. This one's not so tricky, so we're going to have a look at a slightly more difficult one. In the blast furnace, iron oxide is converted into iron according to the following equation. Fe2O3, this is our formula for iron oxide, plus 3CO, carbon monoxide, makes 2Fe, iron, plus 3CO2, carbon dioxide. What mass of iron can be produced from 14 tons of iron oxide? Again, we must start with the balanced equation, and this is given above. Then we need to look again at what we are asked about and what we are told about. So we are asked about the mass of iron that can be produced. And we are told about the mass of iron oxide. We are told that we start with 14 tonnes of iron oxide. So we already have a bit of a problem. Our mole equations only work if our mass is in grams, so we need to convert this. 1 tonne is equal to 1,000 kilograms, and 1 kilogram is equal to 1,000 grams. It therefore follows that if we have 14 tonnes of iron oxide, we must have 14 million grams. Then we can add in the MR value for our iron oxide Fe2O3. If we look in the periodic table, iron has an atomic mass number of 56. This must be multiplied by 2, plus oxygen, which has an atomic mass number of 16, multiplied by 3, and this gives me 160. I can now use these values to calculate the number of moles. So, 14 million divided by 160 gives me 87,500. Now we need the all-important ratio. Okay? If we look at the ratio of iron oxide to iron in our balanced equation, we see that 1 mole of iron oxide produces 2 moles of iron, and I see that from this big 2 here. I can add this into the table, and 2. If we have 87,500 moles of iron oxide, this will produce double the number of moles of iron. So 87,500 multiplied by 2 gives us 175,000. We now need the atomic mass number of iron again, which is 56, plus the atomic mass number of, just the atomic mass number of iron. Now if I want to work out the mass in grams, I take number of moles multiplied by the MR value. So 175,000 multiplied by 56, and this gives me 9,800,000 grams. This could be our final answer, or we could convert it back into tonnes. 9,800,000 grams will give me 9.8 tonnes. But look at what it says in the question. A quick note, lots of people fall into the trap of doubling the MR value because in the balanced equation we have 2 ions. The ratio, though, has already been taken into account when we compare the number of moles, so make sure you only take the MR value for one of your iron atoms, or whatever it might be in a practice question. Hopefully now you can attempt some more difficult ones.